Yes, Nikita, how are you?
Hi, sir. I'm good. How are you?
I'm fine too. I'm fine too. Okay, so are you interested in physics?
Yes. I mean, I didn't learn much about it. But I'd like to learn. So.
Okay, no problem. So here we are. Okay, I'm going to help you out. Okay, this is the topic, and there are some important stuffs we are going to study about. Okay, so what process I am going to forward with? That first of all, I will explain you some topics. Okay, which is Newton's laws and some forces concepts. And
Yeah.
whenever you have any doubt, you can stop me at the very moment, and you can ask me. Okay,
Okay.
remember, I'm
Yeah.
here to help you out. Okay, and then after discussing the entire problems, entire part, then we will start solving some questions as well. Okay, where I'll provide you enough time to think, and then if you can solve the question, it's okay. Otherwise, I'm here to help you out. Okay,
Okay. Yeah.
so so here I'm starting from the scratch. Okay, I'm not expecting anything from you. Okay, whatever I'm telling you, I will explain thoroughly. Okay,
Okay.
so
Yeah.
let's move forward. If you have any doubt before the session, you can ask me now.
No, sir.
Okay, so let's move forward. Okay, can you see the OneNote screen?
Yes, sir.
Okay, so let's move forward then. So here we are going to discuss the topic, what is Newton's laws and force. Okay. In this, what we are going to discuss, first of all, I'm going to teach you all the three laws:
Mm.
the first law, second law, and third law. And then I will discuss the topic, which is weight. Okay, weight is also a kind of force. I will discuss it. Then I will discuss normal force, normal force. Then I will discuss tension force. It is not the tension what you usually know about. It is a
Mhm.
different
Yeah.
tension. Don't worry. Okay, and then I will discuss weight, normal force, tension. Then I will discuss free body diagram, free body diagrams,
Mm.
and there is an interesting topic. Okay, I am saving it. Okay, because that topic is an extra topic. Okay, it is
Okay.
just an X thing because I will analyze that if you are grasping all the things okay
Mm.
easily. Okay, then I will start doing that topic. Okay, otherwise we can directly move toward the questions. Okay,
Mm.
so let's move forward. Then, what is the first law? Look, I'm providing you a situation like how we will proceed in this session. Okay, I am going to explain you a lot. I'm going to write a little less so that you can understand the concept. Okay, but
Okay.
in regular classes, whatever I'm talking, I'm writing the same stuff. Okay, but here I just want you to understand everything. Okay, so that's why I'm explaining everything. Okay, so whenever you're in doubt, again I'm repeating, you can ask me at any
Okay.
moment. Okay, I hope that you are not writing anything. Remember, if there is any kind of formula and special thing you think that you should write, it's okay. But otherwise, everything whatever I'm writing, you will
Mm.
get the all the notes as it is. Okay,
Okay. Yeah.
so what is the first law? First law is also known as the law of inertia. Look, very easy law. Like if a body at rest will remain at rest, if a body in motion will remain in motion by the
Mm.
time an external force is not applied. What is inertia? First of all, it is a resistive property of a body. Inertia is a resistive property of body. For example, if a body at rest will remain at rest, okay, so this is the inertia of rest. Body don't want to change any situation. Okay, and if a body in motion will try to remain in motion, okay, again this is the inertia of motion. Okay,
Mm.
so, for example, like you can see your laptop, okay, and I really hope that your laptop does not have enough power so that it can reach from one room to other room on its own. Is it possible?
No.
Okay, yes, it is
Yeah.
really good if it is not possible. Now, if I want your laptop to reach to other room, then I will ask you, then take your laptop in your hand and take it to other room. So what is
Yeah.
happening? You are providing some extra unbalanced force to the laptop with your hand. Remember?
Yeah.
So this is the concept of first law. If a body in rest will remain at rest. If a body in motion will remain in motion by the time an external force is not applied. Okay, for
Okay.
example, you are in a car. Okay, car is moving with let's say 100 km per hour. Okay, it's quite fast, but it's okay. It is
Mm.
100 km per hour, and What is the tendency of inertia? Car just want to move, car don't want to stop. So
Yeah.
if you want the car to stop, then you will apply some external force. What is the
Yeah.
external force? It is the brake. Okay. So this is the first law. This is the concept. If a body in motion, remain in motion. If a body at rest, remain in rest. By the time an external force is not applied. This is the first law, which is also known as the law of inertia. Any problem?
No, sir.
Okay. So this is just a theoretical purpose. So that's why I explained everything. Okay. Now I am explaining you what is the third law. Okay. Now you can ask me, sir, where is the second law? Okay.
Mm.
So I will explain you the second law after the third law, because second law will take some time. Okay. So I want you to be free. Okay. What is the third law? Third law is known as the action and reaction. Action and reaction. What is action and reaction? Like whenever you are applying an action force on any body, the body is also applying the reaction force of same magnitude in the opposite direction. So I can write it like this: every action has equal and opposite reaction. Every action has equal and opposite reaction. Okay, every action has equal and opposite reaction. It means every force you are applying will have definitely have a reaction force. Okay, for example, like if I'm pumped, okay, I just want to punch someone, so I am punching the wall. Okay, look, if I'm punching the wall, then I'm applying some action force, but as a result, my palm got hurt. Okay, my fist got hurt. Why? Because I'm applying the force, but wall is too adamant. The wall is also applying the same force in the opposite direction. So as a result, I got hurt. Okay, so this is the third law. Every action has equal and opposite reaction. Whatever you're doing in your life, if you're applying force, definitely you are experiencing some external reaction force. Okay, for example, if a rocket is moving in the upward direction, how the rocket moves, you can see the exhaust is moving in the downward direction, so thrust is moving in the downward direction, so the action force in downward direction. As a resultant, and you can say as a reaction force, rocket is moving in the upward direction. Okay, so whenever you're applying a force, there has to be a reaction force working. Okay, any problem?
No.
Are you sure?
Yes.
Okay, so first law is done, third law is done. Now I'm providing you the second law. Okay, it is really important. Second law. So what is second law? Second law actually provide me the definition of force. Okay, look, by the end, first of all, I'm asking a question: have you ever heard this formula F is equals to ma? Ever?
Yeah, I am.
Okay, so if you have heard it, so it would be a little easy for you. Okay, so if I'm providing you what is second law, okay, look, if you are just putting this formula in front of examiner, that force is equals to the product of mass and acceleration, trust me, you will get 100% of marks. There is no problem. But if you're preparing for some higher levels, okay, so this is not the only thing what you have to understand. You have to understand from what sources this formula is coming. Okay, now I'm providing you all those sources. What is the actual concept of second law? Okay, remember, if you forget everything, so just you have to write this formula, you will get everything, you will get all the marks. What is force? Force is the product of mass and acceleration, where m is the mass, a is the acceleration. Any problem?
No.
Okay, so remember, before understanding what is the actual meaning, I have to understand one more concept, which is momentum. Momentum is represented by P. Remember, momentum is equals to the product of mass and velocity. So if I'm looking for the momentum for a body, if a body is moving, remember, every body, if it is moving, will have some kind of momentum in it. Okay, because every body has mass, and if it is moving, it has velocity. So what is momentum? Momentum is the product of mass and velocity. Okay, any problem?
No.
Okay, now I am taking you toward a little deep knowledge. Look, what is force? Force is equals to the rate of change of momentum. The rate of change of momentum. You can see here, momentum is changing with time. Okay, so you can ask me, sir, you just provided me F is equals to ma. Now you are providing me rate of change of momentum. Which one is correct? Both are correct. Okay, both are the result of each other. Now I will provide you how it is true. But if you want to understand the entire concept of second law, you have to understand that force is directly proportional to the rate of change of momentum. So momentum is changing with time. What is D here? D is the differential. Look, in calculus, in mathematics, there is a concept of differentiation. Okay, you know this?
Yeah.
Okay.
Yeah.
So here I'm just taking the small part. Okay. Now, look, as I told you, look, mathematics is the language of physics. So somehow we should understand some concept. Okay. So d over dt. So I can replace p with mass multiplied by the velocity, because what is momentum? Momentum is the product of mass and velocity. Any problem?
Yes.
Okay. Look, in calculus, in the differential calculus, there is a concept. Okay. If you want to differentiate two variables, or you can say if you want to differentiate the product of two variables, like this is the first variable, this is the second variable, I want to get the product of it. So what is the rule you have to follow? Remember, first function as it is, the differentiation of second function, plus second function as it is, the differentiation of first function. Remember this thing always. It is not suitable only for physics, it is for mathematics as well. Okay. If you are differentiating any function of two variables which are in product, okay, you have to differentiate it. So this is the law you have to follow. First function as it is, the differentiation of second function, plus second function as it is, the differentiation of first function. Okay. You can see here why I've explained this. These are the two variables, mass and velocity. So if I want to provide you, so I can write first function as it is, the differentiation of second function, plus second function as it is, the differentiation of first function. Any problem?
Yes.
Okay. Now you can see it very clearly here. Mass is changing with time. Here velocity is changing with time. Okay. Remember, by the time examiner is not providing a situation where mass is changing with time, you will always consider that mass is constant. If somehow directly or indirectly in exam in question it is provided that mass is changing, then it's okay. Otherwise, you will consider that mass is constant.
Okay.
And from differential calculus, one more concept you have to understand, that if you are differentiating any constant term, its answer will be 0. Okay. Whenever you are differentiating any constant term, its answer has to be 0. That constant term can be anything. Okay. So what I have assumed here, mass is constant in this case. So if you understand this concept clearly, then the entire this function will be 0, because dm over dt, mass, what I'm doing, I'm differentiating mass with respect to time. Mass is not changing, so mass is constant. So as I provided you, if I'm differentiating any constant term, it will be 0. So what I'm left with, I'm left with only this dv over dt f. Okay. Any problem?
No.
Okay. Look, what is happening? Velocity is changing with time. Remember, when velocity changes with time, any change in velocity with time is known as the acceleration. Okay. Either I'm increasing it or decreasing it. Okay. It will be considered as acceleration. So F is equals to mass multiplied by the acceleration. Okay. So this is the way how I can prove, okay, from this source, it is coming that force is equals to mass multiplied by the acceleration. Okay. Look, if in exam, the velocity is changing with time, then you have to use this formula, this part, only this part of the formula, then you will get the force. Okay. But if examiner provides you that mass is changing with time, then you have to use this part and you will get the answer. Okay. You can only use one part between these two. Okay. If the mass is changing, then you have to use the second part. If the velocity is changing, you have to use the first part. Okay. So that's how this is the actual concept of second law. That's why I told you that I will explain the second law at the last term. Okay. So again, I'm explaining you quickly. What is the second law? Second law explains me what is the actual meaning of force. Okay. Then F is equals to ma. If you forget everything, you just have to put this value, you will get the answer. Let me tell you, if I have to choose one force, like one definition between this and this, let me tell you, I will choose this. Okay. Because many numericals, maximum of the numericals will be based on the first formula. Okay. But it doesn't mean that second formula is based. There are some numericals which are based on second formula as well. Okay. So as a student and as a teacher, it's our responsibility to know everything. Okay. Especially the topic is really important. Okay. So then this is the actual concept, and F is equals to ma. I just proved that how it is coming. Okay. Now ask me if you have any doubt.
No, sir. I'm good.
Are you sure?
Yeah.
Again, I'm asking, you don't have any doubt?
No.
Okay,
I
look,
learned I
why I'm
learned
saying this, yeah, because by this time student usually have 2 or 3 doubts. Okay, I usually have a tendency, okay, habit to clear that. So very rare moments are there when student have any not have any doubt. So it's good, it's impressive. So should I move forward?
yeah.
Okay, good. Okay, so here I am moving toward the concept, which is weight. Okay, what is weight? Look, weight is also a kind of force. First of all, weight is also a kind of force, but specific force. What is weight? Weight is the attraction force applied by the earth on the body. Okay, weight is the attraction force applied by the earth on the body. Okay, and direction is always in the downward part, or you can say the direction of weight is always toward the center of earth. Okay, for example, if I'm looking for my weight is always working toward the earth. Okay, in the downward direction. Okay, it is easy to understand. Now, what is the formula of weight? Look, you know, as I told you, weight is also a kind of force. So force has the formula is equals to mass multiplied by acceleration. Any problem?
No.
Okay. So what I will do, I will replace the force by weight. Okay, W. Here W is representing the weight. Mass is same, but
Mm,
in this case, because weight is working in the downward direction, so
mm,
in downward direction, I will use the acceleration part as gravitational acceleration. I will not use A, I will use G. Okay,
okay.
so I will use the term G. Remember, both the formulas are analogous. Okay, F is replaced by W, which is weight. M is M. A is replaced by G. Okay, G is the gravitational acceleration, which is working in the downward direction. Okay,
Mm,
so what is weight? Weight is the attraction force applied by the earth on any body, and this is the formula of weight. W is equals to mg, where m is the mass, g is the gravitational acceleration, which is always working in the downward direction.
mm,
Okay,
okay.
any problem?
No.
Okay, good. So let's move forward. Then I'm explaining you normal force. Normal force. Okay, look, there is a myth. What is the myth? Like if I'm providing a situation that for example, your laptop, okay, your
Mm,
laptop is not working, it is just lying on the table, okay, and in someone asks you that how many forces are working on the laptop, okay, then it is
mm,
a basic tendency. If nothing is there, your laptop is alone, then there is no
mm,
force working on the body. Okay, but let me tell
mm,
you, there is nothing like a no force. Okay,
mm,
at least two forces are always working on the body if it has mass. First of all, the weight is in the downward direction.
mm,
Every body, if it has mass, the weight should be working. Okay, so you can see the pen in my hand. Okay, now
mm,
the pen has some mass, so pen has to be some kind of weight. Okay,
mm,
but if the weight is the only force which is working on any body, so
mm,
it is in the downward direction. So why the body is not moving in the downward direction? Look, if only
mm,
weight is the force which is working on the body, then why the
mm,
body is not moving inside the earth? I can say because this is the only attraction force. So there has to be some force which is balancing the weight.
mm.
Okay, and that force which is balancing the weight is known as the normal force. Okay,
Okay.
so for an instant, for any instant of time, if the body is alone, nothing is there, so at least two forces are working, the weight in downward direction, normal force in upward direction, both are in same magnitude but in opposite direction. So let
Mm,
me provide you a situation like this is the mass, so the weight is working in the downward direction. Normal force, which is also equals to mg, it is working in the upward direction.
mm.
Okay, so this is trying to balance the weight. Remember, as I'm increasing the value of weight, the normal force is also increasing. Okay,
Okay.
any problem?
No.
Okay, good. So let's move
Oh,
forward.
actually, I do have one question.
Yeah,
So
please.
this is just a continuation of the third Newton's law, then, right? So, like the equal and opposite
No,
reaction.
no, no. Equal and opposite reaction is applied by some other surfaces. Like when I will
No.
explain you free body diagram, then you will be
Okay.
able to understand. Okay,
Okay.
like if I am not taking the pen in my hand, okay, the pen
Mm,
is has some power. Okay, it is just
mm,
lying in the air. Okay,
mm,
still, if it is lying in the air, the action force is working in the downward direction. You can forget the
mm,
action force. The weight is still working in the downward direction, and the normal force is working in the upward direction.
mm.
Okay,
Okay. Yeah.
here the concept you are getting on the screen, it is in itself a free body diagram, because
Okay.
again, look, I provided you at least two forces are working on the body. Okay,
Mhm.
at least three forces are working on the body. Okay, I will explain you how the three forces are working. For now, it was important for you to understand the normal force. Okay, it is just a force which is balancing the weight of the body. Okay,
Okay.
but here I'm not providing you who is actually applying the normal force. Okay,
Okay.
after some time, when I will explain you the free body diagram, then you will be able to understand how the normal force is coming here. Okay,
Okay.
so but
Yeah.
remember, everybody, the weight is working in the downward direction. To compensate that weight, the normal force is working in the upward direction.
Okay.
Okay, so let's
Yeah.
move forward. Now I want to provide you some tension. So here we are, tension force. Okay, look, tension force is easy. Like, let's say, first of all, tension is always created in any rope, a
Mhm.
thread, a string, okay, a spring. Okay, whenever any substance you are looking at, okay, like a wire, if it is stretchable or you can stretch it somehow for a very small instant, then
Mhm.
tension force will definitely be created in that case. Now, let's say this is the rope, okay, and this is the mass m. So weight has to be working in the downward direction.
Mhm.
Okay, now this time normal force is not working. Okay, this time tension force is working in the rope in the opposite direction. So this is the concept of tension force. Again, it
Okay.
is trying to balance the weight, there is no problem, but
Mhm.
in rope there is tension created. Remember,
Mhm.
tension is always working away from the body,
Mhm.
away from the body. Okay, because the weight is working in the downward direction, so tension is working in the opposite direction, which is in the upward direction.
Mhm.
Okay, so this is the concept of tension. Okay, any doubt in
Mhm.
this?
No.
Okay, so three forces I've explained you. What is weight? Weight is always working in the downward direction, attraction force. Okay,
Mhm.
then what is normal force? A balancing force which is trying to balance the weight of a body. Okay,
Okay.
if there is a weight, there has to be a normal force. Then I
Okay.
provided what is tension for. Tension is always created in some kind of stretchable things. A very little thing, if it is stretchable, then it's okay. Tension is created. Okay, for
Mhm.
example, like I have taken a rope. Okay, the weight is working in the downward direction, so tension
Mhm.
has to be working in the upward direction to balance it. Remember,
Yeah.
tension has always a limiting point. For example, if you are going to increase the weight, okay, and
Mhm.
if you have crossed the limit, so after some time the rope will collapse. Okay, rope will not be integrant. So in that
Mhm.
case, tension force has a limiting value. After some time, it will collapse. Okay,
Okay.
but again, you can increase the weight as per your
Mhm.
choice. Okay, on the other end, if you are increasing the weight, normal force will be increasing on the same way.
Okay.
Okay, so that's how there is a difference. Okay, please ask me if there is any doubt.
No. No.
Okay, great.
Yeah.
Now I'm expecting that I have to teach you that star mark topic.
Okay.
Okay, so tension force, it is done.
Yeah.
Now I'm going to explain you what is free body diagrams.
Okay.
Look, by now you got each and every concept in one go, which was really impressive. You're doing really good. Okay, but physics is divided into two parts. First of
Mhm.
all, the theoretical part or the conceptual part. Okay,
Mhm.
if I'm able to understand it, my only 30 or 40% work is done.
Mhm.
Okay, if I'm able to apply these concepts in the application form, then this is the actual work of physics. Okay, look, whatever I taught you by now, okay, now I'm
Mhm.
going to explain you how these things are used in the application form, how you have to solve the numericals, how you have to solve the question. So
Okay.
free body diagram is a part of that process. Okay,
Okay.
remember, in free body diagram, I will work only for those forces working, forces working on the body, on the body. Okay, so in free body diagram, I will understand or I will conceptualize
Mhm.
only those forces which are working on the body. Okay, this on preposition is really very important to understand, because
Mhm.
in any situation there can be more than 2, 3, 4, 5 forces working, okay, on a
Mhm.
system. Okay, but you have to take only those forces which are working on the body. Okay,
Mhm.
now
Yeah.
let's say this is the mass m, and I am putting this mass on the surface. This is the surface. Okay, let's say this surface is the surface of earth. You can take anything. Okay, maybe it is a table. Okay, so if this is the mass, so the definitely the weight is working in the downward direction.
Yeah.
Any problem?
No.
Okay, so if the weight is working in the downward direction, so the normal force which is working in the upward direction, which is equals
Mhm.
to mg. Now, the question you asked me, I told you at the time, in free body diagram, I will explain this. You can see it very clearly. The mass is put it on the surface. Okay. Weight is the integral part. If the mass is there, weight has to be there. Okay. So weight is working in the downward direction. Normal force is working in the upward direction. But who is applying the normal force? You can see this surface is actually applying the normal force in the upward direction on the body. Okay. If there is any body, your laptop, your pen, your table, your phone, whatever it is. So if it is put it on the table, weight is working in the downward direction, no problem. But the table is applying the normal force in the upward direction. So what is the source? The source is the surface. Okay. Weight is working in the downward direction. The surface is applying the normal force in the upward direction. Okay. Both are same, both are equal. There is no problem. Okay. Now, one more concept you have to understand. If surface is applying the normal force on the body in the upward direction, then as a reaction force, body is also applying a reaction force, okay, on the surface. I'm repeating. Surface is applying the normal force in the upward direction. So body is also applying the reaction force in the downward direction on the surface. Both are equal still. Okay. In this situation, there are three forces working. First is the weight, which is in the downward direction on the body. Second, the normal force, which is working in the upward direction applied by the surface on the body. Okay. Third force, which is working on the surface applied by the body. Okay. So in these three forces, I will work only for those forces which are working on the body. Okay. Remember, I am repeating it. I will consider only those forces which are working on the body. Okay. So you can see it very clearly. If I want to explain you what is the free body diagram, so the weight which is working in the downward direction, it is working on the body, and the normal force, okay, which is also equals to the weight in the upward direction, it is also working on the body. But this reaction force is actually working on the surface, not on the body. Okay. So that's why whenever I'm solving any numerical, I will not consider it, because I will consider only those forces which are working on the body. Okay. Is it okay? Any problem?
No.
Are you sure there are no problem?
No, I'm good.
Okay, good. Okay. So you know that I created a star mark. Okay. So then I'm going to explain you an interesting topic. Okay. Look, free body diagram always have some parts. Okay. Like this is a very easy free body diagram. Okay. On your screen. Okay. Only 2 or 3 forces are working, but let me tell you, there can be 5, 4, 6, 7, 8, 9, 10 forces also working on the body. Okay. If you understand the concept, you can apply them, and you can eliminate the extra forces. Okay. So I am also providing one more complicated diagram. Okay. And if you get this diagram, if you get the concept, then you are going to understand all concept of physics very easily. Okay. So be with me. Okay. I will explain everything.
Okay.
Now I'm going to explain fully. Okay. What is the concept? Look, first of all, I'm explaining the diagram. Okay. Now, let's say this is a rotating wheel, and this is the rope on which a body of mass m1, okay, it is lying, and this is the other part of rope on which other body of mass m2 it is lying. Okay. Now it is tied to the rigid surface. Okay. Remember, rope is free to move on any part. Like it can move like this as well, like this as well. Okay. Now, do you understand the diagram? What is the diagram? Okay. Look, here I'm creating a situation that mass m2 is greater than mass m1. Okay. If mass m2 is greater than mass m1, then it is very easy to understand that this system would be working like this. This system would be working like this. So m1 will be moving in the downward direction, or m2 will be moving in the upward direction, because m2 is greater than m1. Okay. Any problem? Okay. So I will draw the free body diagram for both the masses, m1 and m2. Okay. So, you know, first of all, I'm explaining it for m2. You know what is the direction of the weight? Direction of the weight is mg, or you can say m2g, more specific. It is m2g. It is in the downward direction. Any problem? Okay. Can you see it is a rope? So there also be some tension provided in the rope.
Yeah.
Okay. Remember, the net motion of mass m2 is in the downward direction. Okay. You can see weight is working in the downward direction, but tension is trying to resist it. Tension is trying to work in the opposite direction. Okay. So if I eliminate the tension from the weight. So if I remove the tension from the weight, then I will be able to get what is the net force by which the body is moving in the downward direction. Is it
Yeah.
okay?
Yeah.
Okay, good. But still I'm providing a little example.
Okay.
Let's say this is the mass and I'm providing a 100 Newton of force. Sorry, it is 10 Newton of force in this direction. And I'm providing, let's say it is 3 Newton of force in this opposite direction. Then what is the net force working? Net force working here, it is 7 Newton in this direction. Any problem?
Yeah. No.
Same thing I'm working here as well. Okay, the net situation or the net force working in this direction. Okay, body is moving in this direction. So
Yeah.
the weight is working in the downward direction, tension is working in the upward direction. So if I
Yeah.
remove this tension from the weight, then I will get what is the actual force by which the body is moving in the downward direction.
Yeah.
Any problem?
No.
So look, whatever I'm talking about, I am going to write it. Look, what I'm doing, I am removing the tension from the weight. Okay, this is the weight. I'm removing the tension from the weight. Then I'm getting what is the net force. What is force? F is equals to ma. Okay, what is the net force by which the body mass m2 is moving in the downward direction? Any
Okay.
problem in this equation?
No.
Are you sure?
Yeah.
Okay, good. So this is the net force by which the body is moving in the downward direction. Okay, so this is equation number 1. Now I'm going to draw for mass m1. Okay, now if the body is here, so the weight should be working in downward direction, no problem. Okay, weight has a fixed direction.
Yeah.
Okay, still the weight is working and tension is also working away from the body. I already provided you. Okay, so tension is there, weight is here, but this time you have to understand what is the direction of the net force. Net force is working this time in the upward direction. So this time tension is greater than the weight.
Yeah.
Okay, so if I remove the weight from the tension, in this case I will be able to get what is the net force by which the mass m1 is moving in the upward direction. Okay,
Yeah.
so here what I'm doing, I am eliminating the weight. I am eliminating the weight from the tension. Then I will get what is the net force by which the first body moving in the upward direction. Okay, now you can ask me any question, how these two equations are made, what is the process, any question if it is in mind, you can ask me. Any problem?
No. I got it.
Okay, good. If you got it, maybe I'm teaching really good and you are grasping really good. Okay, so let's move forward. Okay, because the topic is really interesting. Okay, interesting means it is moving toward the tougher side, but it's okay if you are getting in a one go, then it's impressive. Okay, so this was the last topic and this was the star topic. Okay, as I mentioned that it depends, okay, on your response. So your response was good, so that's why I provided you some extra. Okay, it depends on the caliber of students. Okay, so this is the pulley system. I provided everything related to it. Okay, so I'm going to give you a quick revision what you have studied in this session, then we will start solving some questions. Okay, okay, so here we are. What is the first law? First law is known as the law of inertia. If a body in motion will remain in motion, if a body at rest will remain at rest, by the time we are not applying an external force. Okay, it is like a melody. Okay, then third law is known as the action and reaction. Okay, it is suitable for physics and it is suitable for our life as well. If we are doing good, we are getting good. If we are doing bad, we are getting bad. So every action has equal and opposite reaction. Okay, if you're applying force, definitely there is a reaction force working on the body. Okay, any problem? Okay, are you getting my point clearly?
Yes, I am.
Okay, good. Okay, this is the second law. Second law just provide me what is the actual definition of force. Okay, F is equals to ma. This is the actual meaning. But then I provided you force is equals to rate of change of momentum. Okay. Now, according to the situation, you can use any part. You can use this first part. You can use this second part. Depend. If the mass is changing, you can use second part. If the velocity is changing, you can use the first part. In both the situation, you will get the value of force. Okay. Any problem? Are you there?
Yeah.
Any problem?
Yes.
Okay. Now let's move forward. What is weight? Weight is the attraction force applied by the earth on the body. W is equals to mg is the formula of weight. Then explain you what is normal force. If the weight is working in the downward direction, normal force is also working in the upward direction. Okay. Who is providing me the normal force? I explained in the free body diagram. The surface on which the body is lying, that surface is applying the normal force in the upward direction. Then what is tension force? It is always created in the ropes, threads, strings. Okay, and it is always working away from the body. Then free body diagrams, very important term you have to understand. These are the forces which are working on the body. On is the important term you have to understand. Then I
Okay.
explained you what is the concept of pulley. These are the two equation. Okay, the net force. You just have to understand what is the net force. Where is the direction of net force? Okay.
Yeah.
So these are the two equation in on your screen. Okay. I hope you don't have any problem by now.
No, I don't.
Okay, great. Okay, so now I'm going to discuss some questions with you. Okay,
Mm.
you can ask me if you have any doubt. Okay, in between as well. Okay, because as I told you, I'm expecting that you are starting from the scratch. Okay, you are starting from zero. Though in this session your performance is excellent. Okay, because you are grasping all the tough concepts as well. Okay, but still, during the numericals, we have to apply all the concepts. So sometimes it can be difficult as well. So don't worry, I'm here to help you. Okay, in between the question, while you are solving the question, if you have any doubt, you can ask me at the very moment. Okay. Okay, so you can use pen and paper. I am providing you some question in the remaining time.
Okay. 1 second, sir. I will get my paper.
No problem. There is no hurry. Take your time.
Okay. For this one, so you have to get the acceleration, right?
Yes.
To put it in. So is acceleration
Change
the
in
same thing as
velocity with time. Whenever you want to get the acceleration, it is change in velocity with time. So you have to divide the velocity with time, you will get the acceleration.
okay. Can you explain how to get the change in velocity over time? Sir?
Okay.
Yeah.
So I'm solving this question. Okay.
Yeah.
Okay. Okay. So here we are. You know, if someone is asking what is force, force is equals to mass multiplied by the acceleration. Okay.
Yeah.
So first of all, in standard units, what is a mass? Mass is 150 grams.
Mm.
So I have to convert it into kilogram because it is in gram. Okay. So 150 divided by 1000. Okay. Then I will get 0.15 kilogram. Any problem?
No.
Okay. So here, what is the time? Time is 0.1 second. And what is the speed? Or you can say what is the velocity? It is 20 meter per second. As I told you, acceleration is change in velocity with time.
Yeah.
So acceleration, what is the velocity? It is 20. What is time? It is 0.1. Any problem?
No.
Okay. So if you solve this, you will get one extra zero, some simple mathematical calculation. So what is acceleration? It is 200 meter per second square. Any problem? Okay. So if you don't have any problem, so just put all these values in the formula. What is force?
Yeah.
Force is equal to what is mass? Yeah, please tell
I
me
just
what are you
didn't.
saying?
I just didn't convert the 150 grams to kilograms.
Okay, but you got the same value of acceleration.
Yeah.
Okay, then what
I
was
just
your answer?
Well, I didn't calculate it, but I wrote 150 times 20 divided by 0.1.
Okay. Got it. So if you were okay, your concept was good. Your
Yeah,
concept.
my concept. Yeah.
Yeah, it's okay. Yeah, but you have to understand that we are solving in the standard units. Okay. So in standard units, gram is not the part of standard unit. Kilogram is the part of standard unit. Okay. So very basic thing, no problem. You are doing good. So what is mass? Mass is 0.15. What is acceleration? Acceleration is 200. So 0. Okay, if I'm removing this, I'm getting 100. So 100 is removed by 100. So what I'm getting 15 two times, it is 30 newtons. Okay, it is 30 newtons. Any problem?
No.
Okay. Now this is the surprise for you. Okay, I hope this is not the first time you are looking at this question. Okay, have you write those equations, two equations? Did you write those equations? What I provided when I was solving the question equations of pulley?
No, I didn't.
Okay,
But
now you have to write it.
Okay.
Why I'm saying this? Because I understand that you got the concept, but still, just to save the time to attempt more questions, okay, I want you to write it.
Okay.
Because you have to use these equations. If you start getting these equations, then it will take at least 5 to 10 minutes. Okay, in those 10 minutes, we can solve more questions.
Okay. Okay.
Okay, now let's move forward toward the question. So here we are. Okay, I'm just dropping a hint for you. Okay, what is
Mm,
it? Look, in both the equations, the only thing, only force which is same, it is the tension force in both the equation, you can
mm,
see. Okay, so
mm.
somehow by using substitution or by using elimination, okay, if you can eliminate T from both the equation, you will get the answer automatically. Okay, take your time, no
Eliminate
problem.
C.
T, you have to eliminate the tension from both the equations.
Okay. So is it C, G over 3?
Okay, good. Your answer is correct.
Okay.
Okay, till I'm doing the question. Okay, you can check. Okay, so what are the equations? The equations were,
M2G minus T equals M2A.
okay, good. Thanks for helping
And
me. M2G minus T is equals to M2A. This is equation number 1. And T minus M1G is equals
mm,
to M1A. This is equation number 2. Okay,
yeah.
wait a second. Yeah, here we are. So I'm adding both the equation to this equation 2. Okay, this is the concept of elimination.
Mm,
So you know what I'm getting? M2G minus T
mm,
plus T minus M1G is equals to M2A plus
mm,
M1A. Okay,
mm,
so this T is eliminated by this T.
mm,
So what I'm getting? M2G minus M1G is equals to M2A plus M1A. Okay,
mm,
I'm taking G as common. So
mm,
M2 minus M1 is equals to, I'm taking A as common. So
mm,
M1 plus M2. Okay.
mm,
So I want to get the value of A. It is G
mm,
M2 minus M1, and it is M1 plus M2. Okay.
mm,
So what is the value of M2? It is 10. So G,
mm,
it is 10 minus 5 upon
mm.
10 plus 5. So what is
Mm.
the answer I'm getting? A is equals to 5G over 15.
Yeah.
So if I solve this, I will get A is equals to G over 3. Okay.
Mm, mm,
So yes, your answer is correct.
mm,
Let's move forward then.
mm.
Okay, this is easy question. You can check this question out.
Uh, D180, right?
Yes, because the action reaction always working in the opposite direction. So yes, your answer is correct.
Mm,
So let me choose some other question for you to solve. Yes, this is the question. You can try this question.
mm, okay. Mm.
You can ask me any doubt.
Okay. So is so uh,
Action and reaction. You have to
mm,
use the concept of action and reaction in this.
okay.
And remember here you can see 2 kilogram per second. It means mass is changing.
Mm, okay. Uh, okay. So D 5 meters per second.
Okay, have you attempted such type of questions before?
Uh, Not really. No.
I have a doubt because these questions are really good. Okay,
Mm,
and you are getting the correct answers. Okay,
oh,
so option D is the correct one. Okay, which is also
mm,
comment. There is no problem.
mm.
Still, okay, yes, you are doing a good job. So let me help
I
you.
mean,
Yeah,
we've done similar in calculus.
Okay, you have done similar in calculus. Yeah, mathematics is different because physics concepts are different. As I told you, if the person knows some concepts of mathematics, physics can be difficult. But if a person understands physics, mathematics is a part of physics. Okay, it is a understandable thing that mathematics is a language which is used in physics. Okay, so yes, you are doing really, really good because you are the first person to solve this question by now. Otherwise, I have to solve this. Okay, so a block of 4 kilogram. Okay, 4 kilogram. It is resting on the smooth surface. If it is struck by the jet of water, so it means the jet of water is striking with some force, okay, of 2 kilogram per second at a speed of 10 meter per second to find the initial acceleration. It means that jet is applying some force on the block, then block is also applying the same force, reaction force in the opposite direction. Okay, so what is the force applied by the jet? Force applied by the jet, it has to be equals to, okay, you can see the mass is changing. Okay, so velocity multiplied by dm over dt. I hope you use the same thing.
Yeah.
So what is velocity? Velocity is 10, and how the mass is changing? It is 2 kilogram per second. So what is the force? It is 20 Newton of force, which is applying as an action force. Okay, so the force by jet is equals to the reaction force applied by the block. Reaction force. So it is 20 is equals to, what is reaction force? It is equals to ma. 20 is equals to, what is mass? Mass is 4.
4.
And what is acceleration? It is a. I have to find out. So acceleration is 20 by 4. So correct answer has to be, as I praised you. Yes, option D is the correct answer. Okay. Okay. So let's find an interesting question for you. Yeah, here it is. Sand drops vertical at a rate of 2 kilometers per second on a converter belt. Think about this.
Okay.
Do you want to guess the answer?
Well,
Okay, let me provide you a hint. Look,
okay.
the last question you solved, okay, just a, this question is just a half part of that question.
Oh,
If you want to get the force, you have to apply one of those two parts. Okay, I explained you what is force. First is change in momentum. So first is change in speed, and second is change in mass.
yeah.
Okay, you can see what is changing in this question.
The velocity.
Okay, are you sure the velocity is changing? Sand drops vertical at a rate of 20 kilogram per second. With every second, 20 kilogram of sand is dropped. So with every passing second, 2 kilogram of mass is removed. So it means mass is changing with time. But still, if you are getting the velocity is changing, if you want to get the answer from that term as well, though it was incorrect, but still you can get the answer as well.
Okay.
Look, force is equals to, if I'm looking for this question, okay, so I'm providing the complete equation, mass multiplied by the dv over dt plus velocity multiplied by the dm over dt. Okay, so in this case, the velocity is constant, so this term will be 0. Okay,
So it's just 0.4.
exactly 0.4. Can you understand this the level of this question? Okay,
Yeah.
the last question was really tough. Okay, and you solve that question, and let me tell you, this is the problem with some genius students, because they can solve the tough ones, but they are confused in the easier ones. Okay, so yes, your answer is correct. Okay, so 0.4. So the last question I'm going to discuss with you, let's find. Okay, so this is the last question on your screen. 10 1 rupee coins are put over the top of each other.
Mhm.
Okay, so what is the reaction force? Reaction force applied by the 6 coin is equals to the weight of these 4 coins.
Okay.
Okay, so
Yeah.
what is the answer? What do you think?
4. Yeah.
Exactly, 4 mg. Because the question is a little tricky. He's asking that what is the reaction force applied, okay,
Yeah.
on the 7th coin. Okay, so it is understandable that this is not about 7th coin. This is all about all the 4 coins which are over the 6th coin. Okay,
Okay.
so the 4 coins are there. Okay, so what is the
Mm.
weight? Weight is 4 mg. So what is the reaction force? Reaction force has to be 4 mg in the upward
Mm.
direction. Okay, any problem in
So
this?
if they're saying the reaction of the 6th coin on the 7th coin, why are you including the 7th coin in the?
Why I'm including the 7th coin?
Yeah.
Look, 6th coin is applying the reaction force on the 7th coin. Okay, so this is
Okay.
the 7th coin.
Oh,
So
so
in so what is the language? You have to understand the language. The reaction of 6th coin on the 7th coin. So this is the 7th coin. So 6th
okay.
coin is applying the reaction force on 7th coin as well as 8th, 9th, and 10th. So
Okay.
there are total 4 coins which are over the 6th coin.
Okay.
Okay. So that's
Okay.
why I told you, you just read the question a little incorrect. Otherwise, your answer and concept was good. Okay,
Okay.
in fact, in the entire session, whatever the question you solved, your approach was nice. Okay,
Yeah.
but somehow at the end, either you read the question incorrectly, otherwise your calculations. Okay, but still, your approach is nice. Okay, so this is it from my side. One thing what I observe about you. Okay, doesn't matter, it's been a time since you studied physics. Okay, but your grasping power is really nice. Okay, and
Yeah.
your concepts are good. Okay, and the approach which is really impressive, that you are applying all the concept in the application part, and especially as I told you, solve a numerical for the first time. Okay, so it's the first time for my career. So I really hope that you are doing good, okay, for physics and for your life as well. And I hope that we will be meeting in the next sessions very soon. Bye, all the best.
Thank you, sir.